So you can see there are many applications of computer vision. So mainly in my talk, I will discuss the concept of biomedical image processing, biomedical image analysis. So these are the fundamental steps of computer vision. So my input is image. After this, I have to do some image pre-processing, and that is the image processing. And also we can do image segmentation. The segmentation means the partitioning of an image into connected homogeneous region. And after this, we have to extract features, the feature extraction. So you can see here, this is the feature vector. And after this, we are considering the classification. So for this, we can consider pattern classification algorithms, the machine learning algorithms, or maybe the artificial intelligence. So here you can see I am showing the one scheme, that is the image analysis scheme. So first one is image processing. After this, the feature extraction, you can see the feature vector, and finally the classification. So here you can see I want to show the distinction between artificial intelligence, machine learning, and the deep learning. So artificial intelligence means the programs with the ability to learn and reason like human being. And here you can see the machine learning is a subset of artificial intelligence. And what about the deep learning? So I can say the deep learning is also a subset of the machine learning, the subset of the artificial intelligence. And mainly in the deep learning, we use artificial neural networks. So it is a subset of machine learning. So you can see the distinction between artificial intelligence, machine learning, and the deep learning. So for machine perceptions, I can give some examples, like in the speech recognition, fingerprint identification, optical character recognition, DNA sequence identification, biomedical signal processing, biomedical image processing. So there are many applications of machine learning, that is nothing but the machine perception. Also, we can apply the artificial intelligence algorithms or the deep learning algorithms. So what is human perception? So suppose the question is, how did we learn the alphabet of the English language? So mainly we train ourselves to recognize alphabets. So suppose that given a new alphabet, we can use our memory, we can use our intelligence in recognizing it. So that is about the human perception. And similarly, in case of the machine learning also, we have to do the training, and after this, we have to do the testing. So first one is the training, and after this, the next one is the testing. So for training, we need training samples. So that is about the machine perception. So how about providing such capabilities to machine to recognize alphabets? Okay. Professor Kaur, this slide is visible?
Slides are visible, and we can use this slide share, and we can switch to your next slides. So provision is there in Teams platform, so no issues recording your slides.
Okay.
Yes, sir.
So now for pattern recognition, we have the definitions. So what is the definition of the pattern? Pattern means it is an object, the process or event that can be given a name. So maybe I can consider a particular signal, the biomedical signal, that may be a pattern. Or maybe if I consider a face image, that may be a pattern. Or maybe if I consider a biomedical image, that may be a pattern. Or if I consider the fingerprint, so that may be a pattern. So that is the definition of the pattern. After this, the next definition is the pattern class. So it is a set of patterns sharing common attributes. So that is the definition of the pattern class. So in my next slide, I will show what is the pattern class. And after this, we have to do the recognition, we have to do the classification. So for this, we have to consider a classifier that is used for classification of the patterns. So we have the pattern classes, and we can do the classification of the patterns by a classifier. So there are many approaches. One is the statistical pattern recognition, one is the structural pattern recognition, And another one is the subcomputing based pattern recognition. So in the statistical pattern recognition, mainly we can use the statistical tools, the mathematical tools like the Bayesian estimation, the Bayes theory, or other statistical mathematical tools for statistical pattern recognition. The next one is the structural pattern recognition. It is nothing but the description of a particular pattern. So we can consider the structural pattern recognition. And finally, the subcomputing based pattern recognition. So in this case, we can use the fuzzy logic, the artificial neural networks, or maybe the deep learning techniques, or maybe the genetic algorithms and the genetic programmings. So that is the subcomputing based pattern recognition. So in this block diagram, that is actually from my NPTEL course. So you can see I have the patterns, and after this I have to do the measurement. So from the measurement, I have the measured values, and after this we can extract the features. That is the feature extraction. So after extracting the features, we will be getting the feature values. So after this, we have to select the features. So all the features may not be useful. So that is why the feature selection is quite important. So that is called the feature selection. And finally, I am getting the feature vector. The feature vector is X. So feature vector I am getting. And I have the classifier. So you can see I have the database and the decision rules. So based on this, I can do the classification. That is nothing but the decision making. And I can do the hard decision or the soft decision. So maybe we can consider the classical set theory for the hard decision, or maybe we can consider the soft decision, that is nothing but the fuzzy logic, or maybe something like the artificial neural networks we can use. So this is a typical block diagram of a pattern classification system. And in this figure I have shown some classes. The classes are Wi, Wj, Wk. You can see these are the classes. So these are called the class membership space. And I have the pattern space. The pattern space are P1, P2, P3, P4. These are the patterns. And after this, I have the measurement space. The measurement space is M1, M2, M3. So corresponding to the class Wi, I have two patterns, P1 and P4. Corresponding to the class Wj, I have the pattern P2. And corresponding to the class Wk, I have the pattern P3. And here you can see the patterns of different classes are overlapping. Why it is overlapping? The patterns of different classes are overlapping because the patterns of different classes may share common attributes. So that is why overlapping is there. So patterns of different classes are sharing some common attributes. So that is why you can see overlapping of the pattern space. And from the pattern space, I have the measurement. The measurement is M1, M2, M3. So what is the pattern recognition problem? So from the given measurement, I have to determine the class, the corresponding class. So that is nothing but the invert mapping. So that means invert mapping means from the measurement, I have to determine the corresponding class. The class may be Wi, Wj, Wk. So that is the definition of pattern classification. So I have to do the measurement. So measurement is M1, M2, M3. And from this measurement, I have to determine the classes. So mathematically, I can write the probability of Wj given X. That means I have to determine the probability of a particular class given the feature vector. The feature vector is the X that I can determine. So this is the definition of a pattern classification. And you can see the components of a pattern recognition system. So we have the patterns, and after this the sensors are available. So we have to do the pre-processing, and that means we are taking the measurements. After this the feature extraction, and finally the classifier we are considering. But in this case we are considering the learning algorithm. That is nothing but the training of the system. So for this we need the training samples. So by using the training samples I can train the pattern classifier. That classifier I can train by considering the training samples. And here I am showing one simple example. The pattern classification, you can see I am doing the pattern classification based on two features. One is the height, another one is the weight. So the feature vector is X and it has two elements. One is the X1, another one is X2. So X1 is the height, X2 is the weight. So I want to recognize a particular person based on these two parameters. One is the height, another one is the weight. And corresponding to this, I can consider a discriminant function. The discriminant function is Qx. And what is the function? The function is w dot x plus b, that is greater than or equal to 0. Then the class is H. If the w dot x plus b is less than 0, then the class is J. So based on this discriminant function, I can do the classification. This is a linear classifier. And you can see the decision boundary between the two classes. One is the blue class, the blue star I am showing. Another one is the red. So two classes, one is the H, another one is the J. And you can see the decision boundary between these two classes. So w dot x plus b is equal to 0. So this is one example of pattern classification. And we have to select the good features. So that is why the feature selection is important. So all the features may not be important. So what we can consider, we have to select the good features. And in the case of the good features, you can draw a decision boundary between the classes. In the second example, here you can see I am showing the bad features. It is very difficult to draw a decision boundary between the classes. In the first case, what I am considering a decision boundary between the classes. And in the second case, I am not considering, I cannot draw a decision boundary between the classes. And here I can show some of the examples of the decision boundary. The one is the linear decision boundary, another one is the non-linear decision boundary. And I have the regions. The regions are X1, X2, X3, corresponding to the classes W1, W2, W3. And similarly, in the second case also, this is a non-linear decision boundary. X1, X2, X3, these are the regions. So I am considering the classes corresponding to this. The classes are W1, W2, W3, like this. And based on the discriminant function, that concept I am not going to explain. But if you read the pattern classification techniques, then you can see this Z1, Z2, Z3, all these are discriminant function. My input is the input feature vector. And what I have to consider, I have to determine the maximum discriminant function. So suppose Z2x is maximum, that corresponds to the class is W2. So this maximum discriminant function I have to determine. So I have the discriminant function Z1, Z2, Z3 like this. So suppose Z2 is maximum, that corresponds to a particular class, the class is W2. So based on the discriminant function, I can do the classification. And in case of the statistical pattern classification, so one is the Bayesian decision theory. So by using the Bayesian decision theory, we can do the classification. And in this case, I can consider the probability of error, that is the classification error, or maybe the risks of taking a particular decision I can consider. Based on these two criteria, one is the classification error and another one is the risks, I can take a classification decision. And in case of the Bayesian decision, just you try to understand this terminology. One is the classes W1, W2, these are the classes. And I have the prior probabilities, the PW1, PW2, these are the prior probabilities. And also I have the probability density function, that is the evidence. So these are important. So you can see this is the Bayes rule. So we have to determine probability of Wj given X. That is the posterior probability we have to determine. And what information is available? The information is the probability of X given Wj, that is called the likelihood, and that is called the class conditional density. And Pwj, that is called the prior. And evidence has no meaning. It is basically the normalizing factor. So by using these two information, one is the likelihood, another one is the prior, we can determine the probability of Wj given X. That we can determine. So this is the fundamental concept of the Bayesian decision theory. So in case of the pattern recognition framework, already I have mentioned, we need the training samples, we need the testing samples. So by using the training samples, we have to do the training. And after this, we have to do the testing. So suppose in a case of the pattern recognition problem, suppose the alphabet recognition, so 26 alphabets in the uppercase. So first I have to collect the samples of 26 alphabets. And after this, I have to train the algorithm. And so after training, we can do the testing for the unknown samples, for the unknown alphabets. So that is the concept of the training, and that is the concept of the testing. So first I have to collect the samples, that is the training samples. And after this, I have to train my algorithm, train my machine learning algorithm. And after training, what I can do the testing with unknown samples or maybe the unknown alphabet. So what are the patterns? Already I have explained. The fingerprint may be the pattern, handwritten words, that may be the pattern, human face may be the pattern, speech signal may be a pattern, the DNA sequence may be a pattern, the alphabets may be a pattern. So these are some examples. The handwriting recognition. So here you can see these are the patterns. So this is one example. The face recognition is also one important problem in computer vision. So this is face recognition. Fingerprint recognition. This is also one important problem in image processing in computer vision. And now I want to show what is the deep learning. So in case of the deep learning, it is nothing but the cascade of nonlinear transformation. So you can see number of transformations I am considering, and you can see one input image I am showing. It is nothing but to end-to-end learning. So by using this framework, we can extract the information embedded in the input image. So all the information available in the image that I can extract by considering this transformation, by considering these deep learning techniques. In case of the conventional machine learning techniques, we have to extract the features. These are called the handcrafted features. And after this, we have to design the classifier. We have to train the classifier. But in this case, what is the consideration? From the input image, directly we can extract the important information. The low-level information, the mid-level information, the high-level information we can consider. So this is the deep learning techniques. Mainly, it is the advanced version of the artificial neural networks. So you can see the space of machine learning methods. Like this, we can consider the recurrent neural network, convolution neural networks, Bayes NP, restricted Boltzmann machine, GMM, support vector machine, autoencoders, neural net. So these techniques we can use. And some techniques are deep techniques and some techniques are shallow techniques. And you can see, and some techniques are supervised and some techniques are unsupervised. So I will explain what is supervised and what is unsupervised. So I am showing the distinction between the deep learning techniques and the conventional techniques. And some techniques are supervised and some techniques are unsupervised. And some techniques are probabilistics. So mainly in machine learning algorithms, you can see some of the supervised and unsupervised techniques like regression, the decision trees, random forest, the classification like k nearest neighbor, trees, logistic regression, the naive Bayes, support vector machines. In case of the unsupervised, we can consider the singular value decomposition, the PCA, the principal component analysis, k-means clustering. Like this, we can consider association analysis, the hidden Markov models we can consider. And in case of the reinforcement learning, I will explain later on what is the reinforcement learning. But we can consider these are the techniques, supervised techniques and the unsupervised techniques in machine learning. So already I have explained. So what is the machine learnings? We have the label data. And after this, machine learning algorithms. So first I have to do the training. So after the training, we will be getting the learned model. So learned model I will be getting. And after this, from the label data, I can do the prediction. I can do the classification. That means that is nothing but the testing. So I can do the testing. So this is the concept of the machine learning. And in this figure, I have shown the concept of the classification, regression, and the clustering. So classification is nothing but the supervised. The supervised, I will explain what is supervised and what is unsupervised. And also the reinforcement learning, I will explain. But here you can see, I am showing the classification. First case, the classes are class A and the class B. And second one is the regression. That is nothing but the fitting of lines between the sample points, or maybe the fitting of curves between the sample points. And clustering, you can see that clustering is the unsupervised. So I can do the clustering of the samples. So in case of the traditional pattern recognition system, from the input image, I have to extract the handcrafted features. Maybe I can consider the shift, or maybe the hog, the histogram of oriented gradient, the scale invariant feature transform. Like this, we can consider I can extract many features from the input image. And after this, I can apply the unsupervised and the supervised machine learning algorithms for classification. So this is the traditional pattern recognition system. And what is the deep learning? Already I have explained. So first, you can see the first one is the machine learning. So from the input signal, from the input image, I can extract features. And after this, I can do the classification based on these features. But in case of the deep learning, so simultaneously, I can extract the features and I can do the classification. So I can extract important information from the input signal, from the input image, and simultaneously I can do classification. So you can see the distinction between the machine learning and the deep learning. In one case, I have to extract the features. After this, I have to select the important features. And after this, I have to do the classification. In case of the deep learning, directly I can extract the input. Directly I can extract the important information from the input signal, from the input image. So here you can see I am showing the one case. From the input image, I am extracting the low level information, mid level information, and the high level information. So all this information I can extract from the input image. And if you want to compare the deep learning versus machine learning, in case of the deep learning, it requires the large amount of data. And in case of the machine learning, it can train on lesser data. If I compare the accuracy, in case of the deep learning, accuracy is very high as compared to the machine learning techniques. And you can see other things like the training time. Deep learning takes longer to train. And if I consider the deep learning, we need the GPU. But in case of the machine learning, we can consider simple CPU. So I want to show that the distinction between the deep learning and the machine learning. So pattern recognition algorithm means we have to consider the bag of algorithms. And for this, we have to consider the probabilistic framework. And for this, we have to extract the features. So in this case, you can see in this example, I am considering the classification of the alphabet I. One is the capital I, another one is the small I. So how to do the classification? So in this case, the presence of dot in small I, based on this, I can do the classification. One is the capital I, another one is the small I. So the presence of dot, I can distinguish this small I from the capital I, and that can be considered as a feature. So finally, I want to show the block diagram of the pattern classification system. First, the input image is there. After this, we have to do the measurement. We have to do the pre-processing. After this, we have to extract features. We can do the classification. And finally, we can do the post-processing. And for feature extraction, we have to extract the discriminative features. That is, the features should be invariant to the affine transformations like translation, rotation, scaling, like this we can consider. And also it should be invariant to illumination variation. So all these cases we have to consider the photometric variations, the invariant to affine transformation. So all these cases we have to consider. And finally, we can do the classification, and finally the post-processing we can do. So first one is the training, and after this we have to do the testing. So that concept already I have explained. And what is the supervised learning and what is the unsupervised learning? In case of the supervised learning, we have the training samples and we know the class levels. So corresponding to particular training samples, we know the class levels. What are the classes? We know. So corresponding to a particular training samples, so we know the class, the corresponding class. So by considering these training samples, we can train the system, we can train the algorithm. So that is the supervised learning. But in case of the unsupervised learning, that information is not available. So what is available? Only the feature vector X is available. The feature vector X is available, and based on some similarity, I can do the grouping of this feature vector. So the grouping I can do. So that is the concept of the unsupervised learning. So unsupervised learning already I have explained. That is the grouping. So based on some similarity, I can do the grouping. All right. মই seminar ত আছো Punjab University. মই 12:30 মানত যাব পাৰিম. Oh, okay. But 12:30 free. So clustering is that is one is unsupervised learning. Already I have explained. So based on the feature vector, I can do the grouping. That is unsupervised learning. And the clustering is mainly we have to consider the inter-class similarity and the inter-class similarity. That concept is important. So we have to do the grouping. So one is the inter-class similarity, another one is the inter-class similarity that we have to consider. So here you can see the clustering is subjective. So I want to do the grouping here. The first grouping you can see, I am considering the family, Simpson family. So that is one class. Similarly, if I consider school employee, so that is also one class. And if I consider the females, that is also one class. And if I consider the males, that is also one class. So that is why I can consider the clustering is subjective. The clustering is subjective. So based on some similarity, I have to do the clustering. And here you can see, I am finding the similarity between these two images, and I can find the similarity score. Similarly, you can see I am finding the similarity between these characters, and I can find the similarity. And similarly, you can see I am finding the similarity between these two fingerprints, and I can find the similarity score. So that is nothing but the Euclidean distance I can consider. So Euclidean distance between these two patterns I can consider. So that means I have to extract the features and I have to find the similarity between these patterns. So one popular algorithm is the k-means clustering. I think many of you know what is the k-means clustering. So first I have to randomly initialize k number of clusters, and suppose decide the class membership of the n objects by assigning them to the nearest class center. So corresponding to a particular sample, I have to determine the nearest class center based on the minimum distance. After this, for all the samples, we have to do this. After this, we have to re-estimate the cluster centers. And this procedure I have to repeat again and again. And after this, until no changes of the means. So finally, the means will be, the center of the cluster will remain same. So the pictorially I can show you. So these are the samples. So randomly I have to select the centroids. So you can see here I have the three centroids K1, K2, K3. These are the centroids. And in this case, I am considering the Euclidean distance. So now I am finding the which sample is close to a particular centroid. So you can see some are green samples, some are the red one, and some samples are the blue samples. So I have to find the minimum distance between the samples and the cluster center. And based on this, I can decide which sample belongs to a particular centroid. The centroids are K1, K2, and K3. And after this, I have to recompute the centroids after assigning this, because the centroid will be changing. So I am recomputing the centroids. And this process I have to repeat again and again, like this. And you can see, and I have to again update the centroids. So I have to recompute the centroids. And finally, I will be getting the final centroids, the K1, K2, K3, corresponding to these classes. One is the blue class, another one is the red class, another one is the green class. So I will be getting the classes. So these are the groupings. These are the groupings. So these are the this is the concept of the clustering. And that is, you can see in this case, what is the supervised and what is the unsupervised. So in the supervised, I have to consider the training model and the predictive model I am considering. So dark like this, not dark like this. So we have to do the training. In case of the unsupervised, I have to do the clustering. So clustering algorithms I have to apply. So here you can see the training dataset is available. And after this, by considering this model, I am doing the clustering. So just doing the clustering for this. The training dataset I am considering, the finding the so all these training samples I am considering, and based on the similarity I am doing the clustering. But sometimes it is very difficult to find the similarity. Here in this example you can see. So how to find the similarity between these two images? So just for one example I am showing and these two images. So how to find the similarity? Professor Kaur, is it visible, these images?
Yes, sir. Yes, sir. Yes.
So have you seen one dog here?
It's slide number 60, sir.
So I don't know about the slide number. What is the content in the slide? Have you what you were?
So in the 59, it is supervised learning classification versus unsupervised. We are having two picks. And in the
61.
And in the slide 61, we are having the similarity between a face of the lady and the dog, like that.
Okay. So that is meant. That means it is okay. It is okay. This is okay. And finally, I want to define what is the reinforcement learning. So in the case of the reinforcement learning, so one particular action is not so important. One particular classification decision action, that is not important. The group of actions are more important. That means the final goal is more important. So suppose I can give one example, the playing of a chess board. So in this case, what is important? One particular move is not important, but the strategy is more important. So the group of actions are more important than a particular action. That is the concept of the reinforcement learning. So corresponding to a particular good action, I will be getting a reward. But if the action is not good, that corresponds to a penalty. So that is the concept of the reinforcement learning. So one classification action is not so important, but the group of actions are more important. So ultimate objective is to reach the goal. That is, the strategy is more important, corresponding to, as compared to a particular action. So this is briefly the concept of the reinforcement learning. And also another concept is the semi-supervised learning. In case of the semi-supervised learning, we have small amount of label data. So by using this small amount of label data, we can do the supervised training. And also we have a large amount of unlabeled data. For the unlabeled data, we have to consider the clustering techniques. So in case of the semi-supervised method, we have a small amount of label data. So for this, we can apply the training algorithms. That is the supervised training we can apply. But we have the large amount of unlabeled data. So for this, we can consider the unsupervised clustering. So that is the concept of the semi-supervised learning. And regression concept already I have explained. That is nothing but the fitting of a line between the sample points, the fitting of the curves between the sample points. And you can see this is the classifier. So you can see the decision boundary between the classes. The two classes I have shown, one is the green, another one is the red class. The objective is how to determine the best decision boundary between the classes. So I have to find the best decision boundary between these two classes. So that is the objective of the pattern classification. So in case of the classification taxonomy, so one is the generative classifier, another one is the discriminative classifier. So in case of the generative classifier, so one information, that information is very important, that is called the class conditional density. Because you can see in case of the Bayesian decision theory, I have to determine the probability of Wj given x, that I have to determine. But for determination of this, I need the information of likelihood. So that is probability of x given Wj. That is called the class conditional density. So that information is available for that information should be available for classification. The probability of x given Wj, that is called the class conditional density. So in this case of the generative classifier, the parametric and the non-parametric, in case of the parametric, the class conditional density information is available, but I do not know about the values of the parameters. So one example I can give, suppose if I consider Gaussian distribution, in case of the Gaussian distribution, there are two parameters. One is the mean, another one is the variance. Or maybe if I consider the high dimensional case, that is the mean vector and the covariance matrix. So this information is important. So in case of the parametric method, I can estimate these parameters like the mean and the covariance I can determine, or the mean or the variance I can determine. So two popular techniques I think many of you know. One is the maximum likelihood estimation, another one is the Bayesian estimation. So by using these two techniques, I can determine the parameters, but the density from is known. So density from is known means that is the class conditional density information is available. And in case of the non-parametric method, the class conditional density, that information is not available. So we have to estimate the density. So that is nothing but the density estimation. So that is nothing but the density estimation. And there are two popular techniques. One is called the Parjan window technique. Another one is the K nearest neighbor technique. So by using these two techniques, I can determine the density. So in case of the generative classifier, the class conditional density, that information is available. And for this, we have to estimate the parameters. So that is called the parametric estimation. So we can apply the maximum likelihood estimation or the Bayesian estimation. In case of the non-parametric methods, we can consider the Parjan window technique or maybe the K nearest neighbor techniques. In case of the discriminative classifier, that is a class conditional density is not important. So we do not need that information. So what we have to consider, we have to apply some optimization technique to find the best decision boundary between the classes. In the case of the discriminative classifier, the class conditional density information is not important. So we have to apply some optimization technique to find the best decision boundary between the classes. So that is the distinction between the generative classifiers and the discriminative classifiers. So this concept already I have explained. So that is the PDF from is known, that is the Gaussian, non-Gaussian like this we can consider. So this is called the generative classifiers. And here in this case, you can see this is the probability density functions is available. And from this, I can determine the parameters. So this is the concept of the generative classifiers. So based on this, I can take a classification decision. And in case of the discriminative classifiers, so already I have explained. So we have to consider some initial weights of the decision boundary, decision surface. And after this, we have to apply some optimization techniques to find the best decision boundary. So maybe we can consider the artificial neural networks, or maybe we can apply the support vector machine. So these are the examples of the discriminative classifiers. So you can see I am considering the two classes, 1 and 0, and I want to find the best decision boundary between the classes. And you can see some of the classes are linearly separable, And some of the, this is the linearly separable data. So one is the red, another one is the green. So based on this function W1 x1 plus W2 x2 plus B is greater than 0, that corresponds to a particular class. W1 x1 plus W2 x2 plus B less than 0, that corresponds to a particular class. So this is the linearly separable data. And what is the equation of the separable line? The equation of the separable line is W1 x1 plus W2 x2 plus B is equal to 0. So that is the equation of the separating line. And here I am showing one example of non-linearly separable data. So for non-linearly separable data, we can apply the artificial neural networks because they use the nonlinear activation function. So that is why for this type of cases, we can consider artificial neural networks, or maybe we can consider nonlinear support vector machine, we can consider. And one theorem is very important, that is the Kovar's theorem. So this theorem, as per this theorem, suppose the given set of training data is not linearly separable. So what for this what we have to do? We have to transform the training set that is linearly separable by mapping it into a possibly higher dimensional space by considering some nonlinear transformation. So this concept I can show in this here. So in figure A, the samples are not linearly separable. So in the figure A, you can see the samples are available which are not linearly separable. So after this, what I can do? I can do some transformation, the nonlinear transformation. So I can do some mapping into high dimensional space. So in the example A, this is the 2-dimensional space. In the example B, this is the 3-dimensional space. So I can do some nonlinear transformation for mapping the samples from the low dimensional space into the high dimensional space. And if I do this mapping, you can see the samples are linearly separable. So this is the concept of the Kovar's theorem. And after this, finally, in case of the machine learning, this concept is important. One is the concept of the overfitting. So here you see the first example is the decision boundary between the samples, between the classes. So this is not a good decision boundary. So this is inadequate. After this, you can see the next one is the good compromise, the very good decision boundary between the classes. And the overfitting, the last one is the overfitting, that is too much. That is the decision boundary corresponding to the overfitting case between the classes. So you can see in case of the underfitting, the error is maximum during the training and during the testing. And in case of the overfitting, during the training, the error is minimum, but during the testing, the error is maximum. So that is why we have to consider the good compromise, that is the middle one we have to consider. In case of the underfitting, that corresponds to high bias. In case of the overfitting, that corresponds to high variance. So that is the concept of the overfitting. And here also I am showing the underfitting, overfitting case corresponding to these cases, the regression, classification, and the deep learning. So in the deep learning, you can see this is very good. But in this case also, we have to consider this overfitting case. So for this, we have to apply some regularization technique in case of the deep learning. So actually, I have splitted my slide because of it was very big size. So I want to upload the second part of my talk. So it will take some maybe 1 or 2 minutes. Is it okay?
Fine, sir, no issues.
So that is why actually I splitted the PPT into 2 parts because the size was very big.
Now it was very much smooth session.
Okay.
Yes.
Okay.
Yes.
So I'll be uploading my second part just after 5 minutes.
Okay, fine, sir. Fine, sir.
is it visible, this slide?
So it's just loading, sir. Yeah, it's visible now, sir. 154 slides are there totally. Yeah.
So at what time I have to finish this talk?
Sir, actually the talk started around about 10:30. So
Yes.
according to that, you can take the time.
Okay. Can I continue up to 12:30, 12:45 like this?
Yeah, till 12:15 or 12:20. We can have the next session after that. No issues. Because we have got the tea break and lunch break, so we're going to get it short. So we can continue. No issues, sir.
Okay. Up to 12:30, then I will continue.
No, no, you continue up till 12:15, sir. Because it is 10:30 almost it started, or you can continue up to 12:30. But that include the question and answer session also.
Okay. So 12:15, I will stop then.
Yeah,
Okay.
12:15 you will stop and then you can ask the question so that participant can get the answers.
Okay. The next topic I want to discuss about the deep learning techniques, or already I have discussed the fundamental concept of the machine learning. So one is the bio-inspired computing. So in case of the bio-inspired computing, we can consider the fuzzy logic, the artificial neural networks, genetic algorithms, and the genetic programming. So I am not going to discuss all these things, the fuzzy logic or maybe the genetic algorithms and the genetic programming. So briefly, I will discuss the concept of the artificial neural networks. And after this, I will discuss the deep learning techniques. And finally, I will explain the applications in the biomedical image analysis. So many of you know the concept of the artificial neural networks. So mainly it is our
Yes.
neural systems. So here you can see we have the dendrites, so which collect the signal from the cell body. The signal is transmitted via axon, and finally it terminates at the synapse. So this is the biological nervous system. So you can see here also, you can see the signals are collected by the dendrites. So all the signals are summed up. If the sum value is greater than a particular threshold, then the signal will be transmitted via axon. So that concept, if you can see here, one is the left diagram, another one is the right one. So in the right, I am showing this one. So signals are collected by the dendrites. So all the signals are summed up, and if the sum value is greater than a particular threshold, then in this case, I will be getting a signal that can be transmitted via axon. So this electrical equivalent is something like this, the model of an artificial neurons. So I have the signals S1, S2, S3 like this. And I am considering the weights W1, W2, W3, W4 like this. These are the weights of the artificial neural networks. And after this, I have to determine the sum signal I have to determine. So how to determine the sum signal? The sum signal, I can determine the multiplication of the signal with the weights. The S1 is multiplied with W1 plus S2 is multiplied with W2 plus S3 is multiplied with W3 like this. I have to do the summation. That is nothing but the multiplication and the sum up. The multiplication and the sum up. So I will be getting the sum signal. If the sum signal is greater than a particular threshold, so for this I am considering one activation function. So that function is called the squashing function. So based on this, I can consider if the sum signal is greater than this particular threshold, then I will be getting a signal. The signal is S in the output. So this is the electrical equivalent of the electrical equivalent of the biological nervous system. So this squashing function I can consider like this. This is a sigmoid function, and that is the exponential function 1 divided by 1 plus e to the power minus x. So you can see in x-axis I am considering the sum. The sum is greater than this particular value. So then in this case I will be getting the output in the artificial neural network. So in case of the artificial neural network, you have seen I have the weights W1, W2, W3. These are the weights. In case of the fixed networks, the weights are fixed. Okay, so that means the dW divided by dt, that is equal to 0. And in case of the adaptive network, dW divided by dt, that is not equal to 0. So that means I can change the weights of the artificial neural networks. So what is the meaning of this? That means the knowledge of the artificial neural network is available in the weights.
Excuse me, sir. Please share your slides again. We are not able to see. Please share it again. PPT, sir, share it again. Please, sir, share your screen.
Is it visible now? Is it visible?
No, sir. No, sir. It's not visible. It's just now it's visible.
Already I have uploaded.
Yes, sir. Now it's visible. Sir.
Is it visible now? Now?
Yes, sir. Yes, sir. Visible. Now it's visible.
So what is the content in your screen?
Okay. ਸਾਡਾ ਨੈਟਵਰਕ ਗਿਆ ਫਿਰ ਤਾਂ ਮਤਲਬ ਸਾਡਾ ਨੈਟਵਰਕ ਉਹ ਕਿਹੜਾ ਹੌਟ ਆਪਣਾ ਚਲਾਇਆ ਹੋਇਆ ਪਰਸ.
So what is you have which slide you have seen now? Fixed network, no? Fixed network and the adaptive network. Professor Kaur? Hello. So is it visible now? Professor Kaur, your voice is not audible. Is it visible my slides now? But other
Yes, sir. Yes, sir. Slide is there. You are audible and visible.
Which slide you have seen now?
Slide number.
What is the content in the slide?
Content. Just, so it's a neural network continued. Third slide, I think.
Mixed network, no? Mixed
So
network.
sync is not proper, sir. Actually, I know you have covered the slide. It's like now slide number 7.
Okay.
Yeah.
Okay, so then I will continue. Very good.
Yes.
So these networks which are able to sense their weights, that is called the adaptive networks. And in this case, the knowledge in the artificial neural network, the knowledge in the artificial neural network that is available in the weights. So that concept already I have explained. So in case of the artificial neural networks, we have the supervised learning. Another one is the unsupervised learning. The concept is very similar. So in case of the supervised learning, we know the desired output and we can determine the actual output of the artificial neural network. So from the desired output and also from the actual output, I can determine the error. So that information is available. That is the desired output and the actual output. That information is available. So from this, I can determine the error. The error is back propagated to the input to sense the weights of the artificial neural networks. So that is called the supervised learning. So that means the error is back propagated to the input to sense the weights of the artificial neural networks. That is called the supervised learning. In case of the unsupervised learning in artificial neural network, that is nothing but the clustering. That concept already I have explained in case of the supervised and the unsupervised machine learning. So similarly, in case of the artificial neural network also, the supervised concept is like this. So we know the desired output, we know the actual output, and from this we can determine the error. And with the help of the error, we can adjust the weights of the artificial neural network. That is the supervised learning. In case of the unsupervised learning, it is nothing but the clustering. So here I have written about the unsupervised learning in case of the artificial neural networks. So how to do the training? You can see here, I am considering one artificial neural networks, and you can see the inputs minus 0.06, minus 2.5, 1.4 like this. So these are my inputs. And weights are W1, W2, W3. These are the weights. And I'm considering the activation function. The activation function is fx 1 divided by 1 plus e to the power minus x. So corresponding to this, I can determine the output of the artificial neural network. So here you see, I can determine the output of the artificial neural network. So minus 0.06 is multiplied with 2.7. 2.7 is the weight of the artificial neural network. 2.5 into 8.6 like this. I have to do the calculation. And based on these calculations, I can determine the output of the artificial neural network. So how to do the training here you can see. So I have two classes, 0 and 1, and corresponding to this I have the training samples. So that means the training samples are available and the class levels are available. So that is why the supervised learning. So first I am considering the first training samples. So first I have to initialize the random weights. So initialize, I have to consider the initialization of the weights randomly. So randomly I am initializing the weights of the artificial neural networks, and corresponding to this input 1.4, 2.7, 1.9, I am determining the output of the artificial neural network. It is 0.8 suppose, but actually it should be 0 for that particular class. So it should be 0. So what will be the error? The error is 0.8. So that is why I have to adjust the weights of the artificial neural networks. So I am adjusting the weights of the artificial neural network so that the error is minimum. And after this, I am considering the second input. Suppose the second input is this 6.4, 2.8, 1.7, and corresponding to this, I am getting the output is 0.9. That is the actual output. And what is the desired output? The desired output is 1. So error is minus 0.1. So that is the error is minus 0.1. And that error is back propagated to the input to change the weights of the artificial neural network. So that means I am changing the artificial neural network weights. So like this, we have to do the training. That is the supervised training. And after this, we have to do this repeatedly for all the training samples to update the weights of the artificial neural network. And you can see initially I have to consider the random weights, and corresponding to this, this is the decision boundary between the classes. And after this, I am doing the training. You can see the position of the decision boundary. Here also you can see the position of the decision boundary. Here also you can see the position of the decision boundary after the training. So I am just doing the training, and finally I am getting the decision boundary something like this. So this is a non-linear decision boundary I am obtaining by training the artificial neural network. This non-linear decision boundary you are obtaining because of non-linear activation function. That is the sigmoid function I am considering. So that is why I am getting the non-linear decision boundary between the classes. Professor Kaur, is it visible?
Yes, sir. Yes, sir. Actually, I think the participants are just moving the slides of their own. So there is a less sync between the two. So either you should take the control of the slide change, because when the participants are just sliding it, so the control is being shifted. So there is bit mismatch between the slide and what you are presenting. So currently you just tell me the slide number and you take the control so that no participant can just alter it.
So the
Yes.
Slide number, what is the slide number? Slide number is 29.
Okay. So participants, I think that should not just move it because it is showing 23. Okay, fine, sir. 29. Fine, sir, you can continue.
So have you seen the decision boundary in this figure?
Yes, sir. Yes, sir. Yes, sir. It is visible. Slides are visible, no issues. Yeah.
So that is the concept of the artificial neural network training. So briefly, I have explained the concept of the training. And in this case, I am considering the activation function, that is the nonlinear activation function. So that is why I am getting a nonlinear decision boundary. And here you can see if the fx is linear, then in this case, I am getting only the linear decision boundary. Maybe we can get the straight line, or maybe the plane we can get. But if I consider the nonlinear activation function, then in this case, I can draw the nonlinear decision boundary between the classes. So you can see I am getting the nonlinear decision boundary between the classes. And in case of the support vector machine, simple support vector machine, I can draw the linear decision boundary between the classes. So here I am only considering the linear support vector machine. So there are different types of artificial neural networks like MLP, the multi-layer perceptions, the feed-forward network, a feedback network, the Hopfield networks, the competitive networks, the self-organizing networks. So MLP already I have explained. So feedback means the output is fed back to the input, and Hopfield means every node is connected to every other node. So I will show what is the Hopfield networks. So with the competitive networks and the self-organizing network, we can do unsupervised clustering. So one example of the self-organizing network is the coherent neural network. So by using the coherent neural network, we can do the clustering. So these are the competitive networks. So by using the competitive networks and the self-organizing networks, we can do the clustering. So here you can see I have the inputs, and I have the hidden layers, and I have the output layers. So this is the multi-layer, the feed-forward network. That is called the multi-layer perception, MLP. So input layers and the hidden layers and the output layers. And here also I have shown the MLP, the input layer, hidden layers, and the output layers, and the interconnections between the nodes, the interconnection between the neurons. Here you can see. The feedback network is mainly the output is fed back to the input. So sometimes it is called the recurrent neural networks. And what is the Hopfield networks? Every node is connected to every other node, but not itself. And also we have the symmetric weights. The weight from 1 to 3 is same as that of 3 to 1. The weight from 1 to 3 is same as that of 3 to 1. It is, you can see here, weight from 1 to 3 is -2, and from 3 to 1 it is also -2. So this is one example of the Hopfield network. The competitive network, so already I have explained. So with the competitive networks, you can do the unsupervised clustering. So in this case, you can see I am considering the inputs and I have the competitive layers. So with the competitive layer, I can determine the winner. So which one is the winning neuron? And based on this, I can update the winner and also I can update the loser. So I think these concepts already I have explained in my NPTEL course. So if you are interested, then you can see all my videos in the YouTube. So in the YouTube, it is available. You need not register the course. So in the YouTube, this concept I have explained clearly. But today actually I'm just quickly moving all these things because of the internet problem. So I think the participants, you can see the YouTube videos of my. There are many videos. I think 45 videos. So you can understand this concept, the competitive networks. What is the competitive networks? What is the coherent neural networks? That concept you can see from the my video. And this is the self-organizing network. That is also the competitive neural network. And one example is the coherent neural network. So again, we have to determine the winner and the losers. The winning neurons and the losing neurons we have to determine. And based on this, we can do the clustering. So this concept I am not explaining in detail. And that backpropagation training already I have explained. So what is the backpropagation training? That is nothing but I have to apply the inputs to the networks, and after this we have to determine the actual output of the neural networks, and after this we can determine the error. The error is nothing but the desired output minus actual output, and the error is backpropagated to the input, and I can adjust the weights of the artificial neural network. So this is called the generalized delta rule, or it is called the backpropagation training. So this mathematics already I have explained. That is, we have to determine the error, and I have to minimize the error. So how to minimize the error? I have to adjust the weights of the artificial neural network. So like this, I can do the training of the artificial neural network. At competitive learning, already I have explained that we have to determine the winner and the losers. The winning neurons and the losing neurons we have to determine, and after this we can do the unsupervised clustering. And one example is the coherent neural network. So there are many types of artificial neural networks you can see. So there are many neural networks, like you can see the perception feed-forward networks, the radial basis functions. So all these things, you can read from the books. So there are many types of neural network architectures. Now, briefly, I will explain the concept of the deep learning, the introduction to deep learning. So already I have explained. So in the case of the traditional pattern recognition systems, suppose we have the input image, we can extract the input features from the input image. So maybe some handcrafted features we can extract. After this, we can apply the supervised and unsupervised learning for image classification, for image analysis. In case of the computer vision, we can extract these features, maybe the color features, the texture features, or maybe we can consider the color histogram, the gray level histograms, or maybe this type of features like shift features, the hog features, the sharp features we can extract. And by using these handcrafted features, we can do the classification. And you can see this is the traditional pattern recognition approach. So input image is available, and we have to extract the features. So these are the handcrafted features. And after this, we can apply the learning algorithm. That is something like the support vector machine we can apply, or maybe the Bayesian decision theory we can apply. So this type of pattern classification or the machine learning algorithms we can apply for image analysis, image recognition. In case of the deep learning, already I have explained, it is nothing but the cascade of the nonlinear transformation. So from the input image, I can directly extract the important information. So you can see the performance versus the sample size. So you can see the traditional machine learning algorithms and the deep learning algorithms. So if I consider the large amount of data, then the performance of the deep learning algorithms are much better as compared to machine learning algorithms. So I'm considering the number of training samples. The size of the data is very high, then I think the deep learning algorithms are much better as compared to the traditional machine learning algorithms. So you can see in case of the supervised learning, what we are considering from the input image, we can consider the handcrafted features. After this, we have to consider the trainable classifiers like support vector machine, random forest, like this we can consider. And output is nothing but the classification. So whether it is the indoor scene or the outdoor scene, that like this we can consider. So this is the traditional machine learning algorithm. And in case of the deep learning, what we can consider, we can extract important information from the input image. The low level features you can see here, the mid level features you can see here, the high level features you can see here, and also finally we have that the trainable classifier we can consider for classification, for image analysis. So that means from the image directly I can extract the important information present in the input image. So same example I am showing here. From the input image, I am extracting the low level information, mid level information, and the high level information, and I can consider the trainable classifier. So low level information means suppose the low frequency information I can consider. So what is the high level information? High level information is maybe we can consider the edges and the boundaries. These are the high frequency information. Low frequency information means the homogeneous region of the image. But if I consider the boundaries and the edges, that is the nothing but the low frequency, that is the high frequency information. So you can see here again I am showing from the input image you can extract low level features, mid level features, high level features. So like this you can consider in the deep learning methods. So how to consider what is, let us see how it all works. So what is the difference between the artificial neural networks and the deep learning techniques? So this is the artificial neural networks. We have the input nodes. Inputs are x1, x2, x3, x4 like this. And we have the hidden layers. And you can see the interconnections between the neurons. And we have the output. So this is the structure of the simple artificial neural network. And the training concept already I have explained. So that means we have to update the weights of the artificial neural network based on the error. The error is back propagated to the input, and based on this I can adjust the weights of the artificial neural network. So if I consider a simple artificial neural network, here you can see. So I can consider maybe the softmax activation function, or maybe something like the ReLU function, or maybe the sigmoid function I can use. And I can determine the response of the neurons. So already I have shown how to determine the weight is multiplied with the inputs. W1 is multiplied with x1, W2 is multiplied with x2, plus like this I am doing the multiplication and the addition, and we can determine the sum value. We can determine the response of the neuron. I can determine, and if the sum is greater than a particular value, threshold value, then we can get the output in the artificial neural network. So for this I can consider the activation function like this. So in this case you can see, so I want to calculate the number of parameters for the training of the artificial neural network. So I have the inputs, the hidden layers are available, and the outputs are available. So how many hidden nodes? 4 hidden nodes. And how many input layers? How many input nodes? 4 input nodes. So if you see the interconnections, I need how many parameters? 4 into 4 for the input and the hidden layers. And again, you can see the interconnection between the hidden layer and the output node. So that means how many interconnections? 4 plus 1. So that means I need 4 into 4 plus 4 plus 1, that number of interconnections. And if this is for the simple network, but if I consider one input image, The input image is 400 cross 400 into 3. 3 means the RGB image I am considering, not the grayscale image. So that is why 3. 400 number of rows, 400 number of columns, and RGB image I am considering. So how many input nodes? So that is from X1 to X480000. So that number of input nodes are available. And you can see the hidden layers also. You can see hidden nodes are available. And also you can see the one output node. So corresponding to this, number of parameters will be approximately 230 billions. So you can see. And in this case, suppose if I reduce the number of nodes, the hidden nodes, still you can see it is 480 millions approximately. So how many parameters I have to train for this artificial neural network?
Excuse me, sir. Now the slides are not visible. Yeah, now it's visible. See, some disconnection was there. Yeah, now the slides are visible, sir.
There is a delay, I think. There is a delay in your side, I think.
Yes, sir. There was some delay, so slides were not visible.
What you have seen in this slide? Can you tell me?
Yes, sir. Now it's I'm just getting 51 slide number. 51.
Oh, what?
The presentation was stuck on 51 slide. After that, disconnection was there.
So it is 61. In my case, it shows 61.
Okay, sir. Fine. We'll just slide it to 61.
So it is 61.
Okay, sir.
So I think there is a significant delay.
Yes, sir. Delay is there. Actually, slide number is not updating after 57. So that is one of the issue, I think. Because up till 56, it is counting. After 57, when I'm moving on the slide, it is showing 57 on the count for me.
Oh. So is it now available? If the input image is So what is available in this slide? Can you tell me? If the input image is an image.
Neural network, and when I just pressing the arrow, it is just making the network. So I think that's why it is slide number 57.
Okay.
Yeah, sir. Yeah, sir. I'm moving to 61 slide. Fine, sir.
If the input image is an image, so you can see how many parameters. So 230 billion parameters we have to train.
So I'm on 61 slide number. So it is showing some pink, and it is 400 cross 400 cross 3 image.
Yes. Fine. Yes. So in case of this next slide, I am going 62. So neural network, you can see I am considering the input layers and the hidden layers and the output layers. And you can see I am considering the weights, W1, W2, these are the weights. And I'm considering the sigmoid activation function. So I'm not counting the inputs. So how many neurons you can see? The 4 neurons in the hidden and 2 neurons in the output. So that is why altogether I am considering 3 into 4 plus 4 into 2. So that means 20 weights I have to consider. And how many bias terminals? So 4 plus 2, so 6 bias. So in this simple neural networks, 26 learnable parameters. So that is the problem of the artificial neural networks. So we have to train the networks on so many parameters we have to train. So that is why this problem is overcome in case of the deep networks, the deep learning techniques. So that is the problem of the artificial neural networks because we have to train so many parameters. This is a very simple neural network. But if you consider the big images, big video, then in this case also we have to train the networks. Then how many learnable parameters we have to train? That is also a very difficult case, very problematic. So let us see how convolution neural networks help convolution layers. So there are some animations here. So this convolution layer, you can see the filters are available. And from the input image, by using this filter, I want to extract the input information. So I can extract the low frequency information, high frequency information. So all this information I can extract from the input image. So here you can see You can see the marks corresponding to the filter, and I am moving the marks over the image like this. So again, I am showing, I am moving the marks over the image, and I am extracting the important information from the input image. Professor, is it visible? This animation is visible?
Yes, sir. Yes, sir. It's visible.
So this is the function of the convolution layer. And you can see I am considering the filter like this. Some filters I can consider, and I can consider the input image, and I can determine the high frequency information. The high frequency information means the boundaries and the edges. So for this, I can consider the Laplacian marks. So this marks is the Laplacian marks. So by using this Laplacian marks, I can extract this information. The edge information and the boundary information I can extract from the from the input image by using this filter. So convolution is mainly from the input image. I am considering the marks, and you can see I am just doing the convolution. Convolution is nothing but the multiplication and the sum up. That is the convolution, the concept, the multiplication and the sum up. So I have the image and I have the filter. So I have to do the convolution, the multiplication and the sum up. And you can see I am doing the multiplication and the sum up. And corresponding to this, I am getting the output. The output is H1. And similarly, after this, I have to move the marks over the image. And again, I have to do the convolution. And corresponding to this, I am getting the output. Output is H2. So like this, for all the pixels of the image, I have to determine the output. That is the convolved image, or it is called the Fisher map. I have to extract. So number of parameters for one Fisher map is only 4. And number of parameters for 100 Fisher map, it is only 4 into 100. So it is very less as compared to artificial neural network. So that is the advantage of the convolution layer. Professor, is it visible, this animation? Max pooling means the maximum output within a rectangular neighborhood. So by pooling also, I can, pooling is basically the sub-sampling. And also the average pooling also we can consider. So that is the average output of a rectangular neighborhood I can consider. So in this example, I am showing the concept of the max pooling. So I am considering the 2 by 2 neighborhood, 1, 3, 4, 2 like this. So this neighborhood 1, 3, 4, 2. So which one is the maximum? The maximum is 4. That I am considering. Similarly, if I consider I am considering the second neighborhood 5, 3, 3, 1. That I am considering. So corresponding to this neighborhood, the maximum value is 5. That you can consider. And like this, I am determining the output by considering the max pooling. So that is nothing but the sub-sampling. So you can see in convolution neural networks, this is the final structure. So we can extract the features, and also you can see I am showing the convolution layers, and also I am showing the max pooling layers. Professor, is it visible, this convolution neural networks?
Yes, sir. Yes, sir. It's visible. Animation is visible. It's fine.
So I can extract the features from the input image. So I am considering the convolution layer, and after this I am considering the max pooling. So max pooling is nothing but the sub-sampling. So we can reduce the size of the Fisher map by considering the max pooling or the average pooling. And you can see the final classification. You can see the like this final classification I am getting. The living room, bedroom, kitchen, bathroom, outdoor, like this I am getting the final classification. And that is nothing but the object recognition. So here again I am showing one animation. So how to do the convolution and how to get the Fisher map. The convolution is nothing but I have to put the marks over the image, and I have to determine the convolved output. The convolved output is nothing but the multiplication and the sum up. So for each and every pixels of the image, I have to do the convolution, and I will be getting the Fisher map. So that is the convolved Fisher I am getting. So again I am showing these animations. So how to do the convolution, just multiplication and sum up. So for this I am considering the marks, and I am considering the filter, and that is the marks is nothing but the filter, and marks is placed over the image, and I am determining the feature map. So like this, I am doing the convolution. So like this, I am doing the convolution. So in this example also, you can see I am considering one filter. So by using this filter, I can determine the vertical edges. The vertical edges, the vertical boundaries I can determine. So I can apply this filter to extract this feature. So this type of convolution filters I can consider for extraction of important information from the input image. So these are the convolution filters. And you can see I am showing the convolution layer again. So multiple filters I can consider to determine the convolution map or the feature map I can consider. So again, after this, I have to consider the max pooling. So that is maximum from the neighborhood, the 2 by 2 neighborhood in this case I am considering. And I am determining the output, that is the max pooling output I am getting. Professor, this animation is visible now?
Yes, yes, it's visible.
So pooling layer already I have explained. So pooling layer, this pooling layer. So ultimately you can see this is the structure of the convolution neural network. So I have the input image, filter banks are available. So different types of filters are available. And after this, I can consider ReLU activation function in this case. And after this, the pooling layer I am considering. So I am getting the output. So this convolution neural network architecture is something like this. I have the convolution layers, and after this, I have the pooling layers. And finally, I have the fully connected layers for classification. So suppose if I consider that one image, and I can consider this is a bake detector. So how to detect a bake? So for this, I can consider one filter, and based on this filter, I can determine the bake. I can recognize I can recognize the bake of the bird. So in this case, you can see the first I am considering the upper left bake detector. Another one is the middle bake detector. So by using this, I can extract the information to detect the bake of the bird. And for this again, I am telling, so I need a filter. The filter is something like this, and I have to do the convolution. So I will be getting the feature map. So you can see I am considering the filter 1 and filter 2. So like this, I can consider a number of filters, and you can see the input image, and you can see I am doing the multiplication. I am doing the convolution, and in this case, one example is the stride. Stride is equal to 1. Stride means the marks is moved to the next pixel, that is the next pixel by 1 pixel. That is moved by the marks is moved by 1 pixel to the right. So that is called the stride. If suppose the stride is equal to 2, means the marks is moved by 2 pixels. So that means by considering the stride, we can reduce the size of the feature map. So stride 1, stride 2, like this we can consider. So stride 1 means the marks is moved by only 1 pixel. The stride 2 means the marks is moved by 2 pixels. So like this, I will be getting the stride 1, and you can see I will be getting the feature map corresponding to the filter 1. And you can see this filter can determine the diagonal lines. The filter 1 can determine the diagonal lines, and you can see the response. The response is 3 and 3. That is maximum corresponding to a diagonal lines. So that means it can extract this information, that is the information of a diagonal line present in an image. And you can see I am considering the filter number 2. So for the filter number 2, again repeat this for each of the filters. I have to repeat this. So I am repeating this, and I am getting the feature map something like this. So two 4x4 images forming 2 cross 4 cross 4 matrix I will be getting. So that is I am getting after doing the convolution. So in this case, I am considering the stride 1. And for the color image also, because for color image I have 3 channels. the R channel, G channel, and the blue channel, RGB. So for each of the channels, I have to do the convolution. So for the color image, I have to do this. So one is the R channel, another one is the Z channel, another one is the blue channel. So for this, I have to do the convolution. So like this, I'll be getting the feature map. You can see I am getting the feature map, and you can see the fully connected layer. Finally, I have the fully connected layer. So one fully connected layer is there. So for the final classification decision. So here you see, just I am considering the fully connected layer. So that means only I am considering the few parameters. So first I have to determine the convolutions, the filter by considering the filters. And after this, only to connect 9 inputs, not fully connected. But in this case, you can see I am considering the shared weight. That means I am reducing the number of parameters. So that means only few parameters, only very few parameters I am considering, because I am sharing the weights. So that is the importance of the fully connected layer. So I can share the weights and I can reduce the number of parameters. So finally, the complete CNN, the convolution neural network, will be something like this. So from the input image, I have to do the convolution. After this, again, I can apply the max pooling. Again, I can do the convolution. I can do the max pooling. And after this, I have to do the flattening. And finally, I can consider the fully connected feed-forward neural networks for final classification. So this is a typical block diagram or typical sequence of a convolution neural network. So max pooling concept already I have explained. So the max pooling concept, filter 1. So for this neighborhood, I have to determine the maximum value. You can see the maximum value is 3. Corresponding to this, the maximum value is 0. Corresponding to this, maximum value is 3. Corresponding to this, maximum value is 1. Professor, is it visible, this animation now? Professor Kaur, is it visible?
Yes, sir, it's visible. I'm seeing slide 1034. Now 104 slides.
So max pooling, have you seen the max pooling?
Yes, sir.
Okay, then filter 1, filter 2, like this. For filter 2 also we have to consider like this.
Yes, sir, we are seeing filter 1.
Filter 2 I am now considering. So you can see the output of the max pooling. So maximum
Yes,
value is 1. And out of this, the maximum value is 0. Out of this, the maximum value is 3. So like this, I have to do the max pooling. And because the max pooling is nothing but the subsampling. So in this example, I am considering the input image. So bird, if I do the subsampling, then in this case, you can see I am just doing the subsampling, but there is no sense of the object. The object will remain same. It is the bird. So that means subsampling do not change the information content present in the image. So that means I can consider the few parameters. My objective is to reduce the number of parameters of the artificial neural network. So that can be done by considering the convolution layer, by considering the stride, by considering the max pooling or the average pooling. That is the concept. So number of parameters I can reduce by this. So reducing the number of connections, and also we can consider the shared weights, and also we can consider the max pooling. So max pooling concept I have explained. So finally you can see I'm getting the convolution max pooling. So I'm skipping this portion. So complete CNN is something like this: convolution max pooling, flatten like this. And finally you can see flattening I am doing. And after this, after flattening, I am considering the fully connected feed-forward network. So finally, this is the structure of the convolution neural network for object recognition in an image. From the input image, you can see I am applying the convolution, and after this, again I am applying the pooling. Again, I can apply the convolution. Again, I can apply the pooling, and finally, I am doing the flattening, and finally, the fully connected layer I am considering. This concept I am not going to explain autoencoders. So what is the function of the autoencoder? I'm not going to explain because of time problem, so time constraints. So I'm not explaining what is the autoencoder. So I'm skipping this one. So now briefly I have explained the concept of the machine learning and deep learning. So now for this, what are the applications in the biomedical image analysis? So for biomedical image analysis, these are the imaging modalities. Like we can consider the CT scan, that is the computed tomography, or maybe we can consider the PET, the position emission tomography. Maybe we can consider the X-ray image, the mammograms we can consider, the endoscopic image we can consider, the colonoscopy we can consider, the retinopathy, retinopathy we can consider, magnetic resonance imaging we can consider. So these are the modalities. So different types of images we can obtain. And based on the medical image modalities, based on the source energy used for imaging, the energy may be external, energy may be internal, energy may be the combination of external and internal energy. So based on this, you can see we have the X-ray imaging, X-ray mammography, ultrasound imaging, optical transmission like this, because the energy source is outside. And if I consider the internal energy source, maybe we can consider nuclear medicine, PET we can consider. And if I consider a combination of the external and the internal, maybe we can consider the MRI, or maybe the electrical impedance imaging like this we can consider. So these are the images, the biomedical images, the chest X-ray, CT anatomy, brain images, the ultrasound images like this, the PET images, you can see MRI brain images. So all these images you can see. And the interpretation of the medical images, that is very important. So like this, in the first you can see the chest CT image, that is the lung cancer or maybe the COVID-19 detection, the mammograms like the breast cancer, diabetic retinopathy, Alzheimer's disease, and like the tumor detection in the brain, or the polyp detection in the endoscopic images or the colonoscopic images or the videos. So different medical image interpretation is very important. So what is the importance of the medical image analyzing? That is, I have explained. So I am not going to explain this one. And for this, we can design the computer-aided diagnosis system, automatic diagnostic system we can consider. And for the better visualization, we can consider AR and VR. So, but the problem is the challenges in the medical image. The one is the noise. The image is generally corrupted by noise. And also in case of the colonoscopy or the endoscopic, the one problem is the movement of the camera, and also the background may be moving, because the tissues or the muscles are moving, and the specular reflection from the internal organs of the human body. So that is also important case. The region of interest, that is very similar to background, out of focus and the occlusion also that we have to consider, and the low quality images that we have to consider. So these are the challenges in medical image analysis. And also we need the huge domain knowledge, expertise, and mainly we can apply the machine learning techniques or maybe the deep learning techniques for medical image analysis. But the problems or the challenges in medical images analysis, these are the challenges. The main challenge is the noise. Other things like the camera movements, the specularity inside the body parts. Specular means the mirror-like surface. So the light is directly reflected from the surface. That is something like the mirror. So that is the mirror-like surface is called the specular surface. And also the low quality images. So these are some examples. The first one is we want to do the segmentation, and one is the multimodal brain MRI image. That is the low quality image. And the problem in the segmentation, the second one is the colonoscopic image for determination of the polyps. And similarly, for the cancer detection in the skin cancer detections, we can take some images. You can see in the second figure A, B. Professor, is it visible, these images?
Sir?
Is it visible, Professor?
Yes, sir. Yes, sir. It's fine.
So like this, we can see some of the specular components also in the endoscopic images, in the colonoscopic images. So that is very difficult to remove because we have to neglect these specular components. The specular means the mirror-like surface. And you can see the steps in medical image analysis. Mainly, we have to consider the input image. In case of the biomedical signal processing, also the concept is very similar. So I can consider ECG signal, or maybe the EEG signal, or maybe in case of the heart signal, like the PPG signal is also available, or maybe the seismocardiogram signals are available. The concept is very similar. So first we have to get the signal, we have to get the image. After this, we have to do the pre-processing. After this, we have to extract the features, and after this, we have to apply the machine learning algorithms. In case of the deep learning, also the same thing. We have to acquire the images, we have to acquire the signals, the biomedical signals. After this, we have to do the pre-processing, and after this, we have to apply the deep learning techniques like the convolution neural networks for feature extraction and also the classification. So here you can see the steps in medical image analysis. So again, I am showing here the raw image is available. So we can apply some image processing techniques like image enhancement, image restoration, specularity removal, noise removal. So we can apply these techniques. After this, we can extract the handcrafted features in case of the conventional machine learning algorithms, or maybe we can apply the convolution neural networks, or maybe the deep learning techniques we can apply for final classification. So some of the important areas like the lung cancer detection, the breast cancer detection, tumor in the brain that is obtained from the MRI image, and also we can consider the polyp detection, the tumor detection in the colonoscopic images and the endoscopic images. So here you see the detection of the breast cancer. So in this case, we have applied some deep learning techniques. These are my works mainly. So we have also considered this, the detection of the breast cancer. So we can extract some features, the image features. The second example is the CAT for the lung cancer. And also recently we have considered the lung for the COVID patients. So this project is currently going on under me with the AIMS Delhi, All India Institute of Medical Science Delhi, IIT Guwahati, and one medical college. So recently we are obtaining almost 10,000 images, the lung images, and now we are just doing the research in this direction. And surprisingly, what we are getting, the COVID patients who have recovered after 3 and 4 months, I have seen 20% lungs are already damaged, 20 to 25% lungs. I don't know how it can be recovered, but what we are obtaining in the preliminary research, the COVID patients who have recovered after 4 or 5 months, still there are problems in the lungs. So this project is going on with the AIMS Delhi and also IIT Guwahati. So that is also very alarming in case of the COVID. Even after the recovery, also there is a problem in COVID. So like this, the CAT for the brain tumor. So brain tumor detections. So these are my projects under me. And segmentation in medical image video segmentation. So like this colonoscopic videos, the endoscopic videos. So from this we can determine the tumors, the tumor detection, and also we can do the segmentation. The segmentation is very difficult because you can see the background is very cluttered. Specularity is very big problem. And the camera is moving and also the muscles are moving during the imaging. And also the body is moving. So that is why the problem with the camera also. And lighting conditions are also changing. So that is the problem with the segmentation and also the classification. The classification of medical images, like this is my one research area, that is the the colonoscopic imaging and the endoscopic imaging. In my website, you can see my publications in this domain in medical image processing. So mainly I am working on this endoscopic images, colonoscopic images, on also the biomedical signal processing like the seismocardiogram signal and also the PPG signals. This project, this is the colonoscopic image. That is the actually work with the Japanese University of Tokyo and University of Subu University. So currently we are doing this to develop a system to detect the tumors, to detect the polyps in the endoscopic images and the colonoscopic images. So there are many advantages of the deep learning techniques in medical image processing. So I am not explaining. So like this deep learning techniques also we can use. And for this, we can consider the X-ray image, CT scan image, PET image, MRI image, ultrasound image, fMRI image, the microscopic image, and the target mainly the brain, the lung, liver, skin, the breast, prostate, and the heart. So all these things we can consider. So deep learning techniques, you can see the issues are segmentation, detection, classification, and detection of the organs, the segmentation of the objects, and the registration. So one application is diabetic retinopathy detection by using the deep learning techniques. So you can get, there are many research papers on deep learning techniques which can be used for diabetic retinopathy detection. Classification of the skin cancer, that is also one area. So the deep learning techniques are now being used in skin cancer detection. A segmentation of the brain tumor segmentation, that is also you can use the deep learning techniques. So this is about my talks. So for more details, you can see some of my talks in YouTube. And this book, I have this book, M.K.Bhuyan, Computer Vision and Image Processing, Fundamentals and Applications. So this book is published by CRC Press. So another book will be published, that is the Advanced Machine Learning and the Deep Learning Algorithms by McGraw-Hill. And I have two video courses. One is the NPTEL, another one is the pedagogy course on computer vision and applications. So you will get all these materials from this the online courses. You can see videos. So this is my book on computer vision and image processing. So this is a textbook on computer vision and image processing. So this is currently recognized as a textbook in computer vision and image processing. So this is the end of my lecture. So the last part I'm going very quickly. There are many problems in the net. So I think I have covered most of them. Professor Kaur?
Yes, sir. Participants can now unmute and ask questions. Participants, if you really want to ask questions, you can ask. You can unmute. We have changed the controls. First question is there any method to decide the activation function?
Hello?
Hello, sir. I have one question.
Yes. So,
sir, you told about this diabetic retinopathy. So, can you, sir, little bit elaborate, what this
diabetic
type?
retinopathy means suppose suppose someone is a diabetic patient.
Yeah.
So in the retina, basically deposition of the sugars, the fatty things in the retina.
Okay.
So that portion also the obstruction of the blood vessels, and also the deposition of the sugar, the fatty things in the retina mainly. So that we can detect whether it is the deposition in the retina.
Okay.
So we have to take the images, and from the images you can see what is the normal eye and what is the abnormal eye.
Sir, please switch on your camera. We can have the pic of this session because
sir, can we consider the oculogram signal for getting those information?
Tell me.
Click karna print screen. Excuse me, participant. Can you repeat the question?
Participants, have you followed my lectures today?
Yes, it was running smooth afterwards. bit network issue was there, but we have been able to see the slides. No issue.
So
Please repeat your question.
I have skipped many things because of this.
Sir, in continuation of that, sir, I have one little bit I have to ask. Sir, you told about the images for this retinopathy. Sir, can we consider any oculogram signal for analysis of this?
No, there is a
No.
special imaging device for this.
Okay.
I am not working in this domain, but you can see some professors working in IIT Guwahati. Because I am not mainly devoted in this research. I am mainly considering my research in endoscopic images, colonoscopic images, the ECG signal, EEG signal like this, and also the brain tumor and the mammograms. But there is some techniques, the imaging techniques. So from this, you can get the retina images.
Okay, sir. Thank you.
Any other question? Okay, fine. Thank you so much, sir, for accepting our request and just sparing your time from your very tight schedule, I should say. Thank you so much. I contacted you for the first time and you rapidly agree. And because of the network issue, so I think you are very patient. So for that also special thanks from our side. So you provide a deep insight of the deep learning and machine learning techniques, all the things you have covered very well. So we have been able to understand the basics of all these things. Thank you so much, sir.
Thank you.
Thank you.